Hello, welcome back everyone. So we started reviewing the QUIC APIs, I think about a week ago, I want to say, I think last Tuesday. And there's still some stuff that we have to finish. Does anybody remember where we left off? Otherwise I can look it up probably.
I think I barely touched it after finishing the listener. So basically, the listener would produce a connection, and then you can configure it with some options. And that was mostly it. And there was some feedback. I think Manya already incorporated, I assume, right, on the static methods.
I haven't touched the proposal, but if you scroll completely down, there's like Imo put a comment there when summarizing what we decided about the QUIC connection, which was like renaming OpenStream async and accept stream async. What else? I don't exactly. And changing the type for the certificate to certificate 2. I don't know if we want to reopen and chat once more again about the connection itself, or whether we should jump straight into the options for the connect async.
Yeah, I think we were done with the QUIC connection, I think. Or is there any more concerns or questions about what we have on screen right now?
I possibly have one for probably, I guess, mostly Steven, that we choose to do ValueTask. So I think we used ValueTasks in the past for stuff which has chance of succeeding kind of instantly, but I think for like the connect and stuff, we are unlikely to ever finish, instantly or not. So I don't know if you have any thoughts about ValueTasks versus tasks, but it's mostly a question for completeness.
I think they're okay here. We already talked about, it should be ValueTask dispose async rather than void. But for the other ones, certainly for accept, we'd want that to be ValueTask because that should have a strong chance of completing synchronously. And there is still potential benefit even when completing asynchronously. It's just the biggest bang for the buck is when it completes synchronously. And then for OpenStream, I don't have a good sense for whether, I expect that involves a round trip, right? So it's probably much less likely to complete synchronously, but I'm okay with the argument that it's always, any real use of this is always just going to be awaited. No one's going to be putting the result into a dictionary or waiting, using it twice or anything like that. And then there's an argument that, well, if the other API for creating a quick stream is ValueTask, this one might as well be too for consistency, since it doesn't really hurt as long as it is always going to just be awaited. And the biggest downside to ValueTask is the limitation that if you try and do anything else with it, you're in for a world of hurt. But if no one's ever going to try and do anything else with it, then sticking with that, the possibility for synchronous completion, the possibility that there might be a slight, we might choose to optimize for even asynchronous completion and consistency with accept stream async. I think using ValueTask there is okay.
Makes sense. Thank you, Steve.
Yep. I am curious for the close async. What situation is that used versus dispose async?
When you're using the connection, you should always call close async and provide the proper application layer error code. If you don't, the dispose async will close the connection, what we call silently, which means that the peer will wait on idle timeout, because we are not going to send anything over the wire to them because we don't have the code.
I thought we talked about adding some sort of API that allowed you to say, when this connection is closed, this is the error code you should use.
That's for stream, and we have that for stream. That's part of the QUIC connection options. We have a default error code for stream, not for connection.
And that's not relevant to connection as well? I don't know the answer. I'm actually asking.
That's a good question. I'm not prepared for creating the answer at the spot.
Okay. It'd be good to think about just from a consistency with all aspects of the API between Quick Connection and Quick Stream, and then also ensuring that putting this thing in a using block does what you'd expect it to do. It's certainly more important for Quick Stream, as you and I have talked about. One of my overriding principles for Quick Stream is that you can use it via the base APIs. You create one and then you can hand it out to anything else that works with Stream, and it should quote quote just work. So for Quick Connection, it's not as important because there is no base that everyone else knows how to interact with. But there's still people understand what iDisposable and iAsync disposable are, and they understand using blocks, and so ensuring that it integrates nicely with the language is, I think, important.
Right.
Yeah.
I would also say that it might be fine that you have one which is silent and one is sort of the proper close. So I think in both cases, I think HTTP client and Kestrel will try to close it nicely with whatever appropriate HTTP 3 error code that is saying, hey, I'm going away and be nice citizen. I think the silent or quick sort of abort almost might be handy for cases where you really don't have resource, or you're trying to sort of close as cheap as fast as you can. But
I think it'd be useful to write out what we expect the typical use of this API of Quick Connection to look like in terms of its lifetime, and what we would expect, someone to walk up to this type and do with it. Most people that see things that are implementing iAsync disposable and iDisposable will gravitate just towards using, and so figuring out how that code works nicely and as best as possible would be valuable. And not just say, well, we're implementing async disposable, but we don't actually want you to use dispose async because it's not going to do the right thing. So, the API is there, but please call this close async thing instead. I think that's a bit of failure.
That's a fair point. The other part, though, is if need to, we can also add it later. So I don't think it'd be a breaking change, but you should probably look into it.
Well, yeah. I mean, it depends on what is, if, for example, you wanted to provide a default close code to Quick Connection, whatever API or factory or constructor creates the Quick Connection, then yes, it could be additive, but it might also be something that we'd choose to just put into the existing factory arguments. Or I don't remember if that factory has a property bag, in which case, yeah, it would be easier to add in a non-breaking fashion.
Yeah, it would be part of the Quick Connection options here, and they're shared between server and client-side connections, so we could do that. We could still keep the close async for anyone to choose to use a different error code, so it makes still sense to keep the close async there. We can just enhance the options while we talk about them in a minute.
I think that's a reasonable path. Again, it'd still be valuable to write out what the code looks like just to make sure we're happy with it. But yeah, I think just making sure that using works nicely, and if that means having some settable default for the connection, I think that's a fine way to go.
There's a question in chat: does Quick Connect have something similar to socket shutdown, which is different to close?
That would imply that I know how socket shutdown behaves, which is my fault that I don't.
I think the difference, so the shutdown would tell peer, I'm not going to send anything more, but also in our case, it will flush all the data you sent previously, because if you don't call shutdown, we don't guarantee that the data would be delivered. In this case, I think nothing gets it's sent directly on the connection itself. The connection is really a pipe where you open stream and you send the data on the stream. I think that's the difference
Sorry, so this would be more like writes completed on the stream, basically.
or flush on a stream, essentially.
Yeah.
So I didn't quite follow. Are you saying that this one doesn't guarantee that pending data is still sent, or are you saying this is implicitly guaranteed?
So you don't send data on the connection. You open a stream and you send data on the stream. So this is a container for multiplexing.
Also,
So
there
there's
is
no
a caveat. Sorry, Thomas. Also, there is a caveat with the connection, and regardless whether you close it or dispose it, it's going to abort all the streams which are in progress. You have to track them on your own. And this is something we cannot change. For instance, because like the HTTP3 specification has this control stream which you cannot gracefully close, and it's supposed to be like closed with the connection. So neither close nor dispose is waiting for the pending streams to finish. And the streams are the ones which are sending the data.
Yeah, so the follow-up question is, in QUIC being based on UDP probably does not have a fin either.
It doesn't right my remember if there's any verbiage where you can actually signal the ending on a protocol level.
Well, you have fin flag on the stream. You can signal this is the last data which is sent on the particular stream. You don't
But
have
not on a
any,
connection,
like,
right?
connection wide fin flag or anything like that.
Yeah, that makes sense. So I guess then let's go back to the options. Let me copy the whole thing again.
Okay, so the first class, QUIC connection options, is a container for options which are the same for client and server connection. We're starting with the stream limits for bidirectional and unidirectional streams. We might consider renaming them. That was one of the feedback I received because it's not obvious from the name that this means the number of streams the peer can open. Basically, like how many streams I can accept. Then we have idle timeout, which we talked about the close and dispose, and this is basically the time, like if the other side will not send anything on the connection for this amount of time, we will receive like connection being closed by transport. Then we have the default stream error code, which is the one I talked few seconds ago when I talked with Stephen about the error codes. This is the one which we would use for aborting read site on a stream when the stream gets disposed. And probably this is the place where we could add also default connection error code, which we would use in dispose async for the closure of the connection. The last field here is like only suggestion. I do not plan to put this in at this time or like in this release. And this is how we plan to enhance the connection options. And one of them might be a callback that would be called when the endpoint gets changed, either a local or a remote one, because this is feature of QUIC. So you could tell this is delegate call me when the remote or local endpoint is changed. And then we have the client and server options. They mostly differ with the SSL authentication options, which are different for client and for server. And client has also remote endpoint telling to which endpoint to connect. Note that this is an endpoint, so we would accept DNS endpoint as well. But once the connection gets connected, you would read the IP endpoint on the connection, and optionally local endpoint to select from which NIC we want to make the connection. QUIC server connection options only have SSL server authentication options, as far as I know.
So I have
since we
Oh, go ahead. Sorry, Tomas, go ahead.
I was about to say, so since we are not going to implement the endpoint change, should we remove it from the API, or do you want to keep it in there and just not do it? And the other part was for the error code, can we just call it error code and use it for both stream and connection as a default?
I don't think we can use the same error code as in HTTP. Like, we have main customer for this is HTTP3, and I think that the error codes are different for closing stream and closing connection. I'm not 100% sure. I would have to check it out, but I don't think we can use the same error code. And
this is just the default, right? So they can always specify error code whatever they want, right? This is only fallback if somebody misused the API.
That's also an option, yes. We could do that, and we would use it for default stream error code in HTTP3 settings and explicitly used close async. That's a possibility. And the other question was about the endpoint change. No, I do not plan to include it in this release. This is just like, for example, to see how it would look.
But isn't endpoint change a thing that happens inside the transport? Is this not something we can control? We just get an event that the endpoint has changed?
Yes, but do we need a delegate to listen to it?
Yes.
We don't have it. Chris, you need it like right now already? You know that you need it?
I assume we'll need it. Because we do operations based on the IP address.
Okay,
And
then let's.
I don't know that it's urgent. It's just interesting.
Yeah.
Because it's basically
might include-
the IP address can change while you process the request, right? And I don't know even if there'll be actually change at the HTTP level besides logging.
Yeah, we're not quite prepared for that, the implications of that change. But
Right.
we have to
I feel
assume
the same
that
way
we
for-
want to be able to see it.
Right. You know. So
We
it's
may
still
add a
be fair if you
similar
do it-
event. Oh, Thomas?
I was about to say is, would be fair if you defer it to 8?
Oh,
Possibly.
I'm not worried about waiting. I'm just, I expect somebody's going to ask us for it sooner or later. Eventually.
Is there a place in the API somewhere where you query for the current endpoint, like on the stream or something?
There's
That's the local or remote.
endpoint on connection. We have it there. You can query it.
Oh, so those, you might access those twice and you might get back a different answer each time.
Exactly.
How does this connection change? Like, who is initiating the change? The server then?
It's
Only clients
It's-
can initiate migration of the connection to different interface, and server can prohibit it in some parameters that are negotiated at the beginning.
Yeah.
And
So
where's
basically, the
thing-
use case is you can hop between the networks and still maintain the connection. So basically, as you connect to different network, either wireless or wired or whatnot, they try to sort of give you mobility that your download still might be running without interruption.
So I guess my question is, where's this done on the API level?
Oh, like, is there an API to request a change
Yeah.
in QUIC connection?
no, not at the moment.
So basically, it's a change that happens outside of .NET. It's not part of
Yeah,
the
you
API.
just-
Yeah.
Yeah, you disconnect from like your you move out of range for Wi-Fi and cellular kicks in, and then you can reestablish the connection using the same connection ID, I believe.
I see.
Does MS QUIC have that automatically?
MS QUIC doesn't implement it yet, I think.
Yeah.
Okay, so
So we might see, for example, Android connecting to Kestrel, and they might migrate. And actually, if MS QUIC doesn't do it, then they might not migrate either. So I guess I would just kick it out from 7 if you can.
Yeah, the info isn't
basically-
there, therefore, yeah.
Do it as a mobility team on top of QUIC eventually, both client and the server, when we have Androlink implementation supporting it.
So I had a couple questions. I'm assuming the base type here should be abstract and the drive ones are going to be sealed.
Yes.
And then similar to the question I asked last time, this equals 100 on both of these maxes. Is that reflecting some underlying limit? Is that us implying our own opinionated policy? What happens if we didn't set this and we allowed it to be unlimited and so on?
The defaults for these numbers from MS QUIC are 0. So if you do not provide any number here, you won't be able to receive any streams, which might be a viable default settings for us, like not providing default here 400. But it would mean that anyone opening connection and expecting it to accept streams would have to explicitly set those. The hundreds are basically taken from HTTP 2 specification, where like 100 was recommended minimal value or something like that, as far as I remember. But I do concur that this is opinionated and probably not the right number for this API.
Chris, do you have a sense for what ASP.NET would use here?
max bidirectional streams 100 is the H2 default, and probably somewhere we'd start for H3. Max unidirectional streams for H2 is only like 5 for what we actually need. This is only used for control streams.
And just hypothetically, what would happen if we made these in .max value? Like what would go badly?
Denial of service, resource exhaustion kind of things.
Okay, so this is basically trying to get as close to the wire as possible, block additional incoming requests.
Right. Yeah, it also could cause a lot of contention on the connection, which is an issue we've had with HB2.
Right, but that would be something where everything on this one connection is from the same remote endpoint, right? So that would be up to the consumer to say, okay, I'm okay with overloading this one connection. But to your earlier point, it would be problematic for a malicious client because they could overwhelm the server.
Mm. I mean, they can also just open a new connection, but in theory, we have a separate limit for connections at the Kestrel layer.
I see.
It's also something Kestrel can set at their own, and we can default to 0 and throw if somebody doesn't set it, just to make it visible.
Yeah, Kestrel would
basically
certainly
force people.
have to set it.
Yeah,
I
would basically
would not
force
throw
people
for-
to choose.
I don't think we have to throw for 0 because this is default for MS QUIC, and it might be viable. Like basically saying you don't want to accept any streams, you just want to open streams. There might be protocol like that behaves like that.
Or you only want bidirectional and not unidirectional, or vice versa.
Exactly. So like thinking about this more, I'm like thinking that we should leave this default to 0. We already set it correctly in HTTP client, and and Kestrel has defaults that on their own, so I don't see issue to leave it at 0.
If we started at 0, obviously for it to be useful, someone has to set the property. Is there a reasonable error message they'd receive if they didn't?
Once again?
If someone creates a quick connection with both of these set to 0, they can't accept anything, right? The accepting will be broken. Is that correct?
Yep.
So how would they know that they did it wrong if they did that?
Well, I don't think this is wrong per se, but we might throw an exception from accept stream, which basically would say like you did not allow any streams to get accepted. Natalia is raising her hand.
Yeah, I wanted to ask previously on listener options, I believe we discussed required properties. So should this be actually without a default a required property? Because I see that default stream error code definitely should be required property. We cannot just leave it as 0. It might mean something weird.
I'm not 100% convinced about the stream counts that should be required. Obviously, the default stream code has to be required, but that's why I put defaults there, because I don't think that these properties should be required.
I mean, I think the meta point that Steven is trying to make is like, if somebody news up this thing, right, and just uses the defaults, and then they get a weird error message that says can't accept stream, right? Like, how would they know that the problem is go to the quick connect options and initialize the max numbers to something sensible, right? So how would they troubleshoot that?
I would assume that we would throw a better description in the error, which would say you did not provide any stream counts for allowing incoming streams, so you cannot accept stream. So it would like point the user to actually set the connection options properly.
Yeah.
Know that you can still use the connection to open outbound streams. It's valid usage.
Oh, this
so
is
interestingly,
incoming only. Yeah.
So for example, sockets HTTP handler would leave these at 0, right?
No, we have to have unidirectional stream to consume control stream.
So like 4 or 3 or something.
A very low number, much lower than 100, because other than those predetermined control streams or whatever, it doesn't actually want to accept any incoming streams. Is that correct?
Yep.
So as I listen to it, the error might surface on the other side. So basically, if we are not allowing new streams, I don't know if he would get even notification. It's the peer that would probably fail with some like number of streams exceeded or something.
Yeah. Making accept throw does seem like a good mitigation for that.
Radek?
Yeah, like Tomáš said that when we try to open more streams, then we are able to we don't really throw, we just block in the open stream call and basically let it complete once we are able to open the stream. We don't throw when we exceed the limit.
I would add to this that this is implementation detail, which we do in SystemNet QUIC, and this is behavior, like MS QUIC has different options on how to open streams, and this is one of the options we chose to use. Like you can have open stream that basically returns false if there are no available streams instead.
In other words, it's a behavior we can possibly change before the release.
I didn't mean like that we need to change it like from our side. It's what I meant is like you can have different clients which may surface an ability to open stream in different ways. This is not like done by specification that we wait for available streams.
And the peer might not be MS QUIC either, right? So the behavior on their side or whatever they expect or do might be also different.
The rest of this seems pretty straightforward and reasonable. Emo, could you scroll down just a little bit so I can see the server options? Oh, that was all. Okay.
Yeah, so the the only thing I would say is if you don't choose a default value or the default value is 0, which means people have to set it to something, just keep in mind that people are generally not very eager to read docs on these things. They will just set it to some value that makes their code work. And so what people might end up doing, they choose some super high numbers like 1,000 or something to make sure that it actually works, because they have this impression that, oh, I always get this exception, I don't know what to do. Then they just, sometimes do this drastic thing where they set all these numbers to something insanely high. And so that might actually be net-wise worse when everybody's server runs with super high numbers, because they all had this experience that stuff wouldn't work properly before they set it to something. So if your goal is to have a conservative value for most apps, and then people only mess with the number for, reducing resources and make it slightly more efficient, I think forcing them to specify a number might go the other way that you may not want. So it might be sensible to have some, low enough value that you don't have denial of service problems, but also high enough value that most stuff just works.
Would you use different defaults on the client and server?
I mean, I don't know exactly what client and server means in this context. You mean like somebody that sends outbound requests is a client and somebody that accepts inbound is a server?
Yes. And I mean, specifically, QUIC client connection options versus QUIC server connection options might consider different defaults for these values.
Presumably,
like we said, HTTP client doesn't necessarily need to accept incoming streams.
Right.
And we can opt for that. That's perfectly doable.
Yeah.
Do we want to, Manya? Split them or actually move them from the common into the specific parts and make them identical?
We wouldn't move them from the QUIC connection options. We would just introduce the initialization of 2 different values in the specific classes. Like the QUIC client connection options would in their constructor set it to, let's say, 10 and 5 or something like that, and the server 210 or something.
Right.
So, unless there are any more questions about the streams count, should we rename the properties?
I mean, the names seem
to make it clear, it's just to make it clear that it's not the local limit, it's the remote limit. So it's about how many peers you allow ask for.
That was part of my concern, and I think Manya was saying she got some feedback. I think it was the feedback I'd provided, which was like I could, as a client, I could potentially even if my connection options said 5, I could open 1,000 as long as the server was okay with it, right?
Correct.
Yeah, so I think the names are a little misleading in that regard. To me, they sound like they're covering all bidirectional streams, not just ones that I'm accepting.
Right, it's an accept limit.
Right.
I guess then you probably want to have something like max accepted bidirectional streams, max accepted unidirectional streams, or something like that.
I think we were using like accept inbound stream and open outbound stream, or incoming or outgoing. I don't remember which one of these words we chose for the operation. I would probably use like inbound or incoming, then accept. Since it's like ejective.
Also, one point I see in the chat that somebody thought that it was the maximum total number of streams like throughout the lifetime of the connection, but it's actually the maximum concurrent number of streams that can be opened at any given moment. So There is also some room for confusion.
Well, if we include all of these forks in the name, we're gonna have like really long.
I know, I just wanted to mention this. I don't really insist on.
Okay, and do we have any agreement on the default values? Should we introduce different default values for client and server, or should we go with the zeros? Or require them, like that the user sets them in all cases?
I would suggest the client defaults be 00 and the server defaults be 110. Because the server is expected to receive incoming data and the client is not expected to receive anything.
Right.
Sounds good to me.
Going once. Solved.
Then the idle timeout and the default value, we might talk about this as well. By the way, the underlying MS-QUIC default value for idle timeout is 30 seconds. So we might even opt to make this nullable, not require it, and leave it to the default of the underlying implementation, because that was one of the suggestions we talked about in the preview session. So what are opinions on this?
Do we have the ability to query what MS-QUIC is using?
Yes. I'm not sure I'm sure that we don't expose it at the moment, though.
Right. No, I was just saying that we rather than making it nullable, we could just basically say, well, we're not going to choose our own defaults. We're going to use the default of the platform we're built on top of, and just like if you call get, we ask MS-QUIC what it's using, and if you call set, we tell MS-QUIC what to use. We could also. I also don't have a problem here having our own setting. If we think that 2 minutes is better than 30 seconds, we could set it to 2 minutes. And if we think that 30 seconds is the right default, we could just set it to 30 seconds, regardless of what MS-QUIC might change it to in the future.
I think we have 2 minutes because that's what we use for HTTP client. But also this is on the options, not on the connection itself. So it might be trickier to query. We would need to add property to the connection itself, I guess. Or to the provider.
Oh, that was my question.
Decide which. Sorry.
Yeah, sorry. My question was whether we can query MS-QUIC for what its default is rather than what connection's using. It sounds like maybe the answer I got was we can query for what a connection is using, but not what their default is sans connection.
Right.
Got it.
I mean, just from our own education, like you said, you're okay with us having our own policy here. Why do you think that's acceptable for the idle timer, but not for other settings?
Because if the thing we're using under the covers has a policy that is a very determined period of time, then it's not visible. No one can tell whether that policy comes from us or from the thing we're built on top of. And if we wanted consistency for the future, we could choose to just enforce it 30 seconds ourselves now and for the future, even if MS-QUIC changes it. Yeah.
There's no way to query the default value beforehand, as far as I can see at the moment. So no, we cannot tell the user that it's 30 seconds upfront.
We would need to create a connection and see what it's set to, right? Indirectly. And do it once as a static property.
But I'd also be fine just saying we do by default whatever the platform does and just make it nullable. I think that's fine too. It makes it a little weird if in the future we decide we actually do want a default. But I think we've learned from recent experience that changing timeout values is complicated.
So going for nullable and with the platform defaults, documenting that depending on the underlying implementation.
Right.
Did we end up using nullable anywhere else for that concept of defer to the platform?
Connect
I mean,
timeout.
sort of.
You mean within the QUIC API?
Correct.
No, this is going to be the first place. You don't like it. Let's keep the 2 minutes. Kestrel is using them.
In my opinion, either one seems fine. I think the only concern I would have with something nullable, like if it's unconfigured, it might mean no limit, right? So I think we don't want anything that has 0 limits.
That's true.
But as long as there is a limit at some point, I think it's fine to use nullable to say it's unconfigured. We don't actually have our own. I think that's a fairly consistent pattern we have across the framework.
Yeah, I don't have a strong preference here. Whatever you guys want to do.
Yeah.
Didn't we have the same discussion for what was it, the queue in the listener? So like if it's not configured, it's the like something that inside the platform. And I don't think we had it nullable there. We just had it like null or something, 0 or something.
We used 0 because 0 wouldn't be a sensible value, but you could argue that 0 timeout is a sensible value, which means unbounded.
Yeah, we allow 0 timeouts elsewhere. That just means, cancel immediately or timeout immediately.
Aye. Okay, that makes it really great. Yeah, I think the other problem with Q was that it didn't have a number, right? It was just depending on some algorithm that you looked at CPU load or something, right? So at that point, you just don't have one that you can express at all. Like if some QUIC implementation would use some, I don't know, exponential fall off of timeouts based on other factors, then you have the same problem, but then you don't have a timeout really. Yeah. So presumably.
So default or not?
I think the feedback from Steven and Maya would be similar, which is basically whatever you choose. Like just think of it and then decide what you want to do.
Sounds good. And the error code, do we think it's feasible to share it, or do we want to keep it just for a stream and add one for a connection?
Natalia had some concerns there to keeping like a shared error code for stream and for connection, that this might be a pitfall for the user, that they might be confused, and that the spaces for stream and connection might be distinct, so they might not come from the same range. So like, let's say one might mean different value for stream, different semantics for stream and different semantics for connection. And when you would set it here to 1 and we would send it for both stream and connection, that might like break stuff.
So do we want to add a default for a connection as well somehow, or we just defer it and we'll do it in the future if needed? I don't know if you have closure on this one.
I think from my perspective, if we were to add one, presumably it would be called default connection error code. So I would say we can approve that if it's valuable, and you can all play with sample code and see what it looks like. And if you think it's useful, put it in, and if not, leave it out.
Yeah.
I wanted to say that if we want to edit, we have to edit now, because I believe both default stream and connection error codes should be required. So if we edit in the future, it could not be required, and this might be wrong as well.
Well, this is part of what I meant about playing with sample code, because we need to decide on the behavior of dispose async on the connection and on when a connection is in a using block. So we want that to behave reasonably, and if that means there needs to be some default that the user sets or is at least settable, then we need to add it. If it doesn't, or if we really believe that that behavior doesn't need an error code and it can do something more abort-like, then we can leave it out. So I would just say, figure out whether, from a functionality perspective, from a QUIC perspective, we need it or not, and if we do, add it, and if not, don't.
But basically, it's a binary decision. You're never going to change it afterwards.
I personally am more for keeping basically the connect async required, or if you do not explicitly call it, you're gonna do abortive shutdown on the connection or whatever the dispose means, which is doing the silent connection close. Because if we introduce the error code, we're gonna lose the ability to do this basically. But yeah, it's a pitfall scenario when you just use await using on the connection and not call the close async. I don't know.
It's just that's the easy thing, and that's what the language guides you towards, and that's what every analyzer guides you towards. So bucking that means we're likely going to start getting, to whatever extent the QUIC connection is going to be used directly rather than just via ASP.NET or HTTP client. We're going to start getting issues filed like, why am I getting these aborts? I'm using like I'm supposed to. But again, it from an API perspective, I think if we want to do it, we add this property, and if we don't, we don't, and we just need to make sure the API implementations behave the way that users will fall into a pit of success in more situations for. And I think we can leave that up to you to figure out.
We'll play with it in some prototypes and see how the user code looks like, and we come to a decision as a team within ourselves, I guess.
I guess probably the question is see whether closing silently it's viable in most cases, right? If we expect people to always use the close just to provide the error code, then the answer is we should have default and do the right thing automatically. I think that's
sounds good.
That's how I'm sort of hearing Steve's proposal.
Okay.
That's mostly it for a connection, right?
I guess, yeah. So we can move to the first part of the.
Oh, sorry, I had one more question. The client authentication options and server authentication options. So those are non-nullable on purpose, right? We've pre-initialized those to an instance, but we haven't actually configured anything on the instance.
No, that's required. That's going to be required.
Required.
Yeah, because in both cases we need user to provide, for client, we need the user to provide at least ALPN.
Okay.
But it can behave like when you call the getter and it's still null, we can, how did Jeremy called it? Warm it up or something like that, that we will instantiate, so they can just do ... and set the properties, but it has to be done.
So when you say required, you're basically saying you literally would use the C# feature that requires assigning those?
Not decided yet. I haven't had a chance to speak with Fred since the last time because we missed each other on our vacations. But after I speak with him, we'll either introduce constructors with parameters or required attributes to these, or attributes or keywords
Makes sense.
to these properties.
Yeah, I think what Jeremy meant was if you make it get set, you don't have a constructor. Another option you have is you can leave it non-nullable, set it to some instance that effectively is uninitialized, like it doesn't have anything set in it. But then you can just dot into them and configure it whatever you see fit, right? But that highly depends on the type. Then I don't know enough about SSL client and server authentication options, whether that is possible. But if another option that you have is, which we have done elsewhere in .NET, is like you can make it nullable and then just say, okay, it's nullable. So if you didn't initialize it, it's still null. And then when you actually start, trying to do something with the connection, maybe throw and say, sorry, you didn't actually give us any authentication options, right? That's generally
the difficulty
great.
here with. Oh, sorry. Yeah, go ahead, Ivo. Sorry.
Yeah, that's basically the general pattern that we have in the V1 of the framework, right? Where the idea was you configure everything and then you call some method that does something. And if you miss something, then we just fail with an exception and tell you what you should have done differently, right? But that might be more problematic here because you go through, there's not necessarily the one worker function that you call, right? So if it's you may get the exception super late, and then it's very annoying if nothing told you that you have to provide it, right? In which case a constructor or using the C# language feature if required might be better.
I think we're going to have to do that anyway, because the best the C# language feature for required would be to assign this property to a new instance, which might not contain the needed data, right? You need to actually not only have an instance, but it needs to have its whatever properties list populated with various values, and the C# required feature can't force you to do that. All it validates is that you assign this to something.
Right.
So we're still going to have to do that validation the moment you call open stream or connect or whatever the API is.
Yeah,
It's just a hint for the outer, right?
Yeah, it's basically just telling people like you really want a configuration option here. And yeah, if they give you basically an empty object back, then yes. Then at that point when you fail later with an exception, it's like, well, but we told you that we needed it, right? So I think it's kind of more about how early do people get the, I guess how early do people understand the requirement that you need to provide one? That's really more like the decision.
With client connection options, that's like pretty straightforward because you would instantiate and call connect async, and which would immediately give you the error that you didn't fill everything up that's necessary. But with server connection options, since you're providing those in callback when the new connection arrives, it's much harder to do. And the only way we can basically report something missing is by logging an error. There's no vehicle to tell the user that something's missing in the server authentication options.
Oh, because you would just start rejecting incoming to.
Yeah. Yeah.
Yeah, that's the worst of all worlds, right? It's like, yeah, you didn't fill something in and then nothing fails. It's just stuff doesn't work.
Yeah. And
Yeah.
I don't know if we want to do something about it at the moment.
Well, that seems to be a general problem with how servers work, right? In which case, your general remedy is you log aggressively, right? I think you kind of want to have, it's probably already the case. I'm not sure that, assuming you built an ASP.NET app and then something uses QUIC, that stuff would show up by default, right? You don't have to jump through hoops to enable logging for QUIC connections or something like that. Like as long as they normally show up and then you immediately have a log message that says, sorry, reject the connection because you didn't configure authentication options correctly, then that might be good enough, right? It's always bad when you log, but then the log is not on by default. And then people have to jump through hoops to get the log messages, because then that means in the default case, nothing shows up, but stuff doesn't work and you have literally no idea where to look.
Yeah.
We can table this, and again, I think, yeah, at this point, I think the QUIC is still, the reg QUIC, it's really for early adopters. So if we find a way in the future how to propagate errors on the server side, we might run around 4.8.
Right. I mean, presumably for .NET 7, like the expectation is not that users are using QUIC. It's more like stuff that we have uses QUIC, right, under the covers. So we wouldn't.
Mostly, there might be some early adopters, but again, predominantly, I think be consumed by HTTP implementations.
Right.
Okay, so going for runs.
I mean, what you have on screen
Agreed.
right now is incomplete in the sense that we don't know which path is viable, right? So that's kind of, it's just the thing you have to think about and then make a decision on, I guess.
Yeah. But what I think, basically the properties that have some default values at the moment, not that we're going to follow the exact values as you see them, but they're going to be not required. And the ones that do not have default values, they're going, and are not nullable, are going to be required by the user, either via constructor or via required keyword. Yes, David, you are too late. We're not reopening that.
Here we go. I like the spirit.
So streams?
Yep.
Or emo typing notes?
Yeah, I just recorded the last thing. All right.
This
There
one's
goes the
going to
second
be the
hour.
hardest.
I was about to say this. Streams are always difficult, so. Is the other one easy, or is the other one also involved? Oh, the other one is also involved. Never mind, then maybe we should just get the stream done.
Okay, so what the API proposal shows are the additional properties and methods that are not part of the stream itself. That's like implied the stream API. And let's start. So the stream ID, that's ID of the stream.
Should you talk
Go on.
about how the stream is used? Or is it clear at this point?
Maybe we can just scroll a bit down. There's client and server usage. So for client, you would open a new stream via existing connection. You would write some data. When you write the last data, you would, there are two options. You would either call write async with endstream saying to, which means that you finished with the writing side of stream usage, or you would call regular write async and then extra method called complete writes, which does basically the same stuff as endstream to. And then you would read data until something's coming. The usual stream usage until the read async returns 0. And the dispose async is called by the await usync. And on the server side, you would accept stream from an existing connection. You would read data until there are some data. You can use the reads completed property. That's something we're gonna talk about more when we get to the API shade, but the stream itself has two task properties, one for reads completed and the other for writes completed, because basically peers can shut down reads or write sides for the other side. I'm not expressing myself exactly nicely, well, I hope you understand. And if you can scroll down a little bit. And yes, basically what the writes completed async does is that's your private method, which basically registers to listen to when the other side calls writes completed. That's something Kestrel actively uses, and this is like simplified version of the code from Kestrel itself. Any questions?
So I don't understand exactly, like, what is the purpose of this writes completed thing? Like, what happens if I dispose but didn't call complete writes?
If you dispose without calling complete writes, the dispose itself will complete the writes for you. We use it explicitly here so that the other side knows that your write has completed and they can start writing. Like in case you have like write everything and then the other side, when it reads everything, can write back you the data.
So the directions are completely independent. So you can like close your site, similar to the shutdown when you say, hey, I send a fail, I'm not going to write anything more. But you can still read data, for example.
I guess what I'm struggling with is like, why why would you need complete writes? Why is it not implicit, I guess?
Because the other side would still be waiting on read async.
I think the answer
And
is
they
it is
would-
implicit, but there are scenarios where you want to be able to shut down one side of the communication earlier. So like if you think of, you know, request response in HTTP 1.1, for example, you might send up your request and then say, okay, I'm done writing, and and then the server might choose to wait until you're done writing to start sending down the response.
I see.
That's sort of what we call shutdown on socket. So you can say shutdown for read or shutdown for write. So this is similar, but it's on a stream. It's not on a connection.
And why is it not asynchronous? It doesn't send any data? I would expect it to have to send something to the server, to the other side, to say I'm done.
There's extra property, task property, which gets completed when the complete writes are completed. It basically returns task that would be returned from this, but it can also be completed in other scenarios. Like in scenario when the peer, because there's also function called abort, so the peer can basically tell you that they don't want you to send any more data. And that's the moment when the task would get completed. So we do not return task from complete writes, but you can get a task that gets completed when the complete writes are done as well.
Either locally or remotely.
Yeah, exactly.
Is there any reason not to call this complete writes async and have it return the same task as writes completed?
Yeah, because you have to have the ability to get the task without actually firing off the operation that completes your writes.
No, I'm not saying instead of writes completed. I'm saying also have writes complete writes async return the same task.
I guess that's possible. We could do it.
Yeah, I guess stream complete writes initiates an async operation, right? Potentially, right?
Yes.
And then
Yes.
the actual result is effectively implicitly awaited by me calling stream.read async, right?
No. That's separate.
Basically, if you wanted to await it, you would call stream.complete writes and then await stream.writes completed.
Exactly.
I see.
Do we expect, are there scenarios where you would want to call complete writes and not await for writes completed?
I would say in most cases,
And why is that?
because you don't care at this side, I would say. Like, if you think about the equivalent in the write async with endstream true, the write async overload with the endstream true will not wait for the complete writes task. It will return when the send itself is done. So that's question whether if we would introduce complete writes async to return task, whether we should change the behavior of write async which accepts end stream true, and have the write async return different task in case end stream is true or is false.
So complete writes, then, I think what you're saying is complete writes isn't an async operation. You're saying it immediately transitions the stream into a mode where writes are disabled. It might do some other stuff related to the protocol, or might kick off some other stuff related to the protocol, but that's no different than whatever background processing is happening on the connection on your behalf anyway.
I guess so. Like, if you call write async, then you call complete writes, and then you immediately call write async, you're gonna get an error.
Right.
Right. So effectively, what you're saying is
there's a difference between the internal state and the getting acknowledgement from the other side.
right.
And the
But
task
I
is
guess what I'm saying is
about
those,
yeah.
they are different. And so the act of completing writes isn't an asynchronous operation. It's right. It's the moment you call complete writes, you've transitioned the local stream into a mode where writes have been completed.
Yes.
At some point later, the other side might acknowledge that, but no one would ever say, I want to wait for the act of transitioning my local stream into a completed writes mode. They would never await that. Or let me rephrase my question, because I'm not making sense. In what scenario would someone write complete writes await stream.writes completed?
I don't think we have a use case for this.
Okay. Then complete writes is a space synchronous operation. It just so happens that it's named similarly to the property.
Right.
Yes.
I think part of the confusion is that the property is going to get the task it returns will complete for two very distinct reasons. One of which is the server, the remote issued an abort. The other is the local called complete writes.
Yes.
Or did the write with the fin flag, right?
Yep.
Chris, what is your comment in the chat about?
Sebastian's trying to consume some recent changes. It's not related to anything you're currently talking about.
Oh, okay. I was really confused.
And I'm looking at this API on Quick Connection and I was like, WTF?
Got it. Okay. I thought you were
There's-
talking about something we were talking about and I was really confused.
Off topic, but
Got it.
relevant to adjacent APIs.
Okay, cool. Mind you that I think there's some oddities here around naming or around consumption or something, but it seems like complete writes is fine as a void. It's basically just instantly transitioning the local stream into a state complete for writes. And there might be some additional work that the background quick connection is doing then, but.
Can we propose a better name since we understand what it does?
No, I think it's a fine name. I mean, it mirrors what we use for similar concepts elsewhere.
I was actually wondering about shutdown and read in the right direction, like we have on a socket. Because
do
that's
that
a
as well.
concept people. Because
Can
that's
you
concept people
shut down-
understand.
Does that is there a complete reads? Is that a thing?
No, but you can abort reading, which basically tells the other side that they should stop writing and their writes completed task gets finished.
So that task is actually the remote party requested you to stop.
Yep, as well.
Right, so that one probably could use a different name.
I use the naming, like we have the same for reads completed, writes completed, and I use the naming from channel, which uses similar naming. And yeah, basically it's a task, and if it has an exception, it means that the other side aborted, and if it's completed successfully, it means that the other side called complete writes or the thin flag.
So what happens if, maybe this is handled at the protocol layer, what happens if concurrently the server aborts and the local code calls complete writes?
That's something that I believe resolved at the MS QUIC or the underlying implementation layer, and we're gonna get a event from MS QUIC which tells us what's the actual result, which we will set to the task.
Might be also a race condition, right? Kind of by design.
Yeah, I guess I'm just wondering what ASP.NET's going to do in response to, you know, if I guess I'm still perplexed by the fact that both the remote aborting and the local successfully saying I'm done writing both map to the same property. Maybe it's not a big deal. Maybe that's expected and it's just how QUIC is designed. But it feels a little strange.
Well, it can be seen as this task completes once the writing direction of the stream is closed, either gracefully or abortively from either side.
Right. What does ASP.NET do here? I'm just curious, Chris, in this mock-up that Manya has in writes completed async, what does ASP.NET do in response to knowing that writes are completed?
Let me think. Oh, okay. I know what this is. There's a thing in the HTTP3 spec where the request body doesn't have to tell you how long it is. And so you have a hard time gauging if a request even has a body when it first arrives, unless you sit there and read from it. And that might not finish, or that may finish or not. You shouldn't just sit there and wait for it. So this mirrors the other side where it says write and end stream, so that you can get those messages into a single packet and the server can read the request headers and know immediately, oh, I've got the headers and there is no body. Getting that guarantee up front makes processing the request a lot easier.
I didn't 100% follow. I understand the scenario you're describing, but I'm not sure how this writes completed callback plays into that.
That's reads completed.
Oh, that's reads completed. Sorry.
Yeah. The writes completed, if I may, the writes completed are used like basically listening for the abort read from the other side, because like the server might take a while to generate the data to send, or it might be like streaming scenario and long living streams or whatnot. So like you might not have a pending write async to get notified that the other side stopped listening to your data. And that's why, that's for what this task is used, basically to listen for stop sending from the other side. So that's the use case.
So when we said that writes completed is signaled either by an abort from the remote or by calling complete writes, that's not actually the case. It's always that we're being notified that the server has stopped receiving. And the reason for that might be because we told it to. or it might be because it chose to, but either way, it's the server coming back and saying, I'm done.
Yeah, it's a remote complete. Yes.
So I think that the name of the property, as Kristen suggested, is really strange. At least as it relates to the method name, because it sounds like it's complete. It's getting signaled because we called complete writes, but it's not. It's getting signaled because the remote side has stopped reading.
The writes complete is going to kick off operation which will complete the task, regardless the other side stopping the receiving or not. So it's not just the other side telling you stop sending. It might be you, which says like, I'm done with writing, and that's the moment, like when this information gets propagated over network back and forth,
right,
and acknowledge.
That's what I'm saying.
This task.
It's not what I'm trying to clarify. And what I believe you said previously is that complete writes isn't initiating something that, regardless of what the remote is doing, it eventually causes the local task to complete. Rather, complete writes is basically sending something to the remote. It's not doing anything with writes completed. It's sending something to the remote, and the remote is coming back and say, yep, acknowledged, I will not be reading anything more. And that acknowledgement is what causes writes completed to transition.
Yes.
In which case, it's always something coming from the remote that causes writes. It's the server basically saying, yep, I'm done, for good or bad. I'm done. That causes this property to be raised, or this property to be signaled.
Whether or not it's in response to something you initiated.
Right.
It's ultimately a server acknowledgement.
Right. That's what I'm trying to confirm. And I believe the answer is yes.
Yes.
So it's remote reads completed.
Oh no, that's disgusting.
But that's what it is, right? Whether we go with a cleaner name, that's the concept. Because it really has nothing to do with whether our side has finished writing. It's whether the remote has finished reading. And maybe the remote has decided to finish reading because we told it we're not going to send you anything more.
But when we tell it that we are not going to send anything anymore, they cannot change their mind about it.
Well, apparently there's a race condition, right? They could be aborting concurrently.
Yes, they can.
I think those properties will be cleaner. We can figure out the names, but I sort of agree with the direction Chris was heading, that it'll be cleaner if it's referring to I have stopped reading or you have stopped reading, rather than I have stopped reading and I have stopped writing, maybe because you had stopped reading.
Conceptually also, if you say I'm finished writing, you don't need to wait for that, right? You kind of know that from the application logic, or you better be. Whereas you have the task to know from a server that they are done, right? That's sort of mechanism to deliver asynchronous notification.
This also seems to map, the concept also seems to map better to what Chris and Manya described as the purpose of ASP.NET's writes completed async, which is ASP.NET wants to be notified when the remote has stopped reading for cleanup purposes.
One more thing to add. Sorry, I just had to recheck my notes. The writes completed may transition to its final state if you call abort write, which you can. And that's happening immediately.
What is abort write?
Sending reset stream.
No, is that a method on QuickStream?
Yep, we have abort method for writes and reads. You can abort both of them at the same time or individually.
And that will synchronously cause writes completed to be signaled?
Well, not synchronously, because we do everything asynchronously, including like setting the tasks. But yes, from the perspective of the MS QUIC implementation, this is going to happen synchronously.
But it's basically error case, right? So it's saying, hey, I'm aborting, I don't really care, I just want to clean up, and like I'm going away.
Yeah, I mean, both Natalia and Radek commented in the chat that both the spec and MS QUIC use terminology that refers to what the server has decided, or what the remote has decided to do, rather than what you've decided to do.
So can we come up with a good name?
Reading completed and peer reading completed. I don't know, something along those lines, or whatever we use to describe remote reading completed.
So what's the concern with the current naming? It's just not clear how it's related to the remote. Is that what you're saying?
It's confusing. To me, it suggests that it's something on, if I'm talking to you, Emo, it's basically saying I have finished writing. Yeah, writes completed. But in reality, it's saying that you, Emo, have stopped reading.
I see.
Well, it means that the write side of the stream is closed, and the reads completed means that the read side of the stream is closed.
It doesn't, because you call writes complete writes, and it's closed, but you might not get the event for quite some time.
I actually don't think that MS QUIC waits for confirmation from the peer to do this. We say complete writes, and there's just some scheduling on some specific thread which does the all processing for the connection. So that's why we get the event sometime later, but there is no network involved in completing writes, like locally saying, hey, this is the end of stream.
Oh, really?
I would have to check the sources.
That's not what was. So that changed. I mean, if that's true, that changes things. But that wasn't what was previously described.
I have in my notes that it's when the MS QUIC receives acknowledgement for the fin flag. I think I've checked it in the code, but please recheck it after me. I might have made a mistake.
Okay, I'm not 100% sure. I just think that that's what I saw. So I will check. I will check meanwhile.
Since we're just talking about the name of a property rather than, or the name of two properties rather than, whether they should exist or not, which no one's disagreeing with, why don't we just table the naming, follow up, and come back to it, and we can move on to other things.
Right. That's basically where I was heading as well.
Can we scroll up to the API shape?
Oh.
Please. Because this was the usage. So I guess we have a stream ID which comes from the specification. I don't think there are any questions about it. We have a stream tag.
My only question is just, could it be ID rather than stream ID? Unless stream ID is like terminology used in the specification or something.
Somebody would have to click on that link.
Again, you can follow up afterwards too. Just
What about
it's quick stream dot, so it's obviously
The streams
it's just ID. It means
yeah. Yeah, I mean, it seems to me logical to do that. I mean, I think it's quite regular to have things like customer or company, right? And you just say .id. You don't repeat where it's coming from.
Do we have other example where we have ID on some object?
I mean, it is pretty common when you deal with databases, right? Where you have like a customer, an employee, whatever, and then they have an ID property that is basically the int in the database.
Yeah, I think it'd be fine. Less letters.
Okay, this is quick exception. Emo, could you click on quick stream, one tab to the left?
Sorry, I am.
Thanks.
Multi-window handling is hard.
Then we have the stream type, which we may or may not include. That's like up to the API review commission whether we should do it, because this means whether the stream is unidirectional or bidirectional. We're using the same enumeration when you open outbound stream. You can get the similar value from can read and can write properties, which are part of the stream itself. So this is whether to include this unidirectional, bidirectional specification coming from specification property or not. You can get the same value from can read, can write.
Similar, right? Because the problem is the properties, if you close the stream on one direction, the can write can become false, but it doesn't change the type of the stream. We had a problem before.
what can you elaborate on? I don't have a strong opinion either way. We can keep it or not, but can you elaborate on what you mean by it doesn't change the type of the stream? What's the difference between a unidirectional stream and a bidirectional stream on which I've shut down one direction?
So let's say you have a bidirectional stream. Go ahead, Maya.
No, go ahead.
So on the bidirectional stream, you can read and write, right? And it's a property when you open a stream as such. But let's say you or one of the sides closes the stream for one direction. It doesn't change if the stream was open as bidirectional or unidirectional. It just says at this moment I cannot longer write. Whereas if you have a property on it, you know whether the stream was opened as unidirectional or bidirectional, and it stays as such forever.
Right, no, I understand. I was asking more in terms of practical terms. I guess my question could be asked a different way: is what will someone do with stream type? Like, is it if I had opened a connection to you and then I shut down my writing, so that it now is unidirectional because I can only receive, I can't write.
No, that's not unidirectional.
What's that?
Sorry, that's not unidirectional. Unidirectional can write, cannot read.
Oh, okay. The terminology is weird then, because that is unidirectional. It's just a different direction. It's you're saying unidirectional implies writing.
No.
Implies writing, yes.
That's weird from a terminology perspective.
That's specification.
I think that's weird from a .NET API perspective.
Back to your question, Steve, about the cleanup. We had some issue, I think, in the HTTP client. I don't remember the details, but we were basically trying to figure out what time of stream it was. I think we tried to, I remember now, we tried to determine if a given stream was a control stream or not by querying if it's unidirectional or not. And the cleanup logic was messed up because we basically, the type of stream changed in duration of the stream. And again, it could be fixed. It's just one reason why I think Jeff originally open an issue saying we should have a property, and that's why we added. Also, could be Boolean if you choose to.
I'm like I said, I don't have strong opinions about the property as long as there's a real use for it. If there are things that we'll do with it or that are valuable to do with it that you can't do with can read and can write, even diagnostic purposes, if there's a value in knowing that the stream was open for one of these things, even if you close the direction, like it's fine. I just want to make sure we're not just tacking it on just because we can.
I remember that when I went through the APIs with you, we were talking about the connection, and we were talking about the accept stream async, and you were asking me how do I know which type of the stream is that, and I replied, yes, there is a property on the stream which tells you which stream type is that and which corresponds to the other side of the accept, which is open stream async, which accepts the same enumeration telling QUIC whether we are going to open unidirectional or bidirectional stream.
Right. Yeah, I mean, this is just mirroring the value that you passed into whatever that API is.
Yes, like from the other side, from the peer.
Right.
One.
Yeah, we talked about the reads completed, writes completed, and I think apart the naming, we are agreeing that we should keep them and just maybe change the naming. And then we have the abort, which is what I said earlier, which can also finish the writes completed, and you can abort either reading or writing or both sides at the same time. That's abort. And as well, this one does not return task the same way as complete writes. Both of these operations basically kick off operation that either closes or aborts reads or writes side of the stream.
So after I call abort,
yes,
what else do I have to do with the stream to go away?
Dispose it.
And I can dispose it immediately.
Yep, because like we're gonna implement async disposable, which is going to be the real implementation of the disposal, and the dispose gonna delegate to dispose async, and the dispose async will wait for the proper events from MS QUIC telling us that we can release all the underlying structures and whatnot.
Okay.
So basically, when you dispose it, it takes a while for us to safely release the resources.
That's
it's
fine.
also back to the question.
Async was invented, right? It was because things might take a while to clean up.
Yeah, it's also back to what Manya described. Doesn't matter if you abort only one side. Would that change the logic in the dispose? I mean, if you abort both directions, then it's what you describe. It's exactly what you said, right? So you say, hey, I'm done with both sides, and I dispose, then basically cleanup happens and everybody happy. But if you abort only one side, I think, then if you dispose, we would use the default abort code or error code, whatever that we name it, and we would abort the missing side of the stream, and then basically we would go back to the cleanup.
Not exactly. It depends on the side, because we want the QUIC stream to behave the users to be able to use QuickStream the same way as a stream. So the dispose will either, if read hasn't completed, it will abort read, and that's the error code which is going to be used. And if write hasn't been completed, it will do the equivalent of complete writes, not abort write. Because if we would abort,
so
then
yes, so it will flush data essentially and gracefully.
yes.
When you say if reads haven't been completed, how does it know that?
You either read to the end by getting 0 from read async, or you wait for the reads completed.
So dispose async will wait for reads completed?
No, it will abort it. It will abort reading side.
Even if you've already read to 0?
No.
How does it know that you
Only
read to
if-
0 or not?
Yeah, it does know.
It doesn't. It knows some internal implementation detail allows it to know.
Yes.
Okay.
So basically, you're either reading from the stream and you reach the end, and then we know, or you don't read from the stream and we receive a signaling from the other side saying, "Hey, I'm not gonna write," or they send you abort.
And from let's say I know that I'm going to be getting 100 bytes from the server. So I don't read to 0, I read 100 bytes. What happens when I then dispose?
If that was the agreement between the both sides, and well, I think you might hit a race condition here. What we talked about, it depends on the way the other side is sending the fin flag. If they send the fin flag immediately together with those 100 bytes, no abort read would happen because the read's completed, or the read would be completed the moment you the moment you receive the 100 bytes, not particularly read them. But if the fin flag from the peer went in its own packet, you might hit the race condition between receiving the fin flag and calling the dispose, which might not know about the fin flag yet, and basically aborting the read side.
What, as a user of QuickStream, I'm the one who's reading the 100 bytes.
Yeah.
If dispose async calls abort, how does that manifest for me? Does dispose async throw an exception, or from my perspective, everything was hunky dory?
From your perspective, everything was nice.
And then what does the other side see? If the other side wrote its 100 bytes and doesn't care anymore, what does it see?
We might send, stop sending it. I guess it depends. It depends on the race condition. It depends how the MS QUIC or the underlying implementation resolves the race between the fin flag and between the abort read. And I don't have an answer for that at the moment.
So if they use a .NET API, right, the task would either finish this exception or not. That's the race condition you're describing.
Yeah. Radek?
I think that when the sender calls write async and write completes with those 100 bytes and you don't call anything else, or maybe you then just close or dispose the stream, then you are not going to observe any exception in this case, because we don't throw exception when you write complete writes and the stream was already aborted from the other side, or anything like that. So the race condition would pretty much stay hidden. In this case, it would surface if you would try to write something more, possibly. But I think it wouldn't surface in the scenario you described.
I'm trying to. The previous thing we just discussed about being able to use these as streams, that applies to both sides of the connection. So I want to make sure that if, the server created a QUIC stream, the client created a QUIC stream, they handed them out to other components to just interact with as they otherwise would any other stream, which won't provide access to complete writes, won't provide access to abort. It's just read and write and dispose. I want to make sure that that behaves nicely. And I can't tell if that's the case or not. It sounds like it's definitely the case if there's no previously agreed upon higher level protocol and you read to 0. It sounds like you're saying that should, in all situations, work well. But there's potentially some less than ideal behavior that we haven't gotten to the bottom of if you instead agreed on, if this was HTTP 3, if this was HTTP 1.1, and the server sends content length 1, 2, 3, 4, 5, the client might only read 12,345 bytes and not read to 0. And so I'm wondering if in that situation, do things still behave sort of nicely on both sides?
From a perspective in HTTP 1.1, right, you don't care if you get reset or fin afterwards. The protocol is stated that at the HTTP level, you read the bytes as defined, and transport really doesn't matter anymore.
Right. I used to use HTTP as an example, but
right.
If someone was doing their own protocol on top of stream that happened to be QUIC streams, would it sort of behave nicely or not? It's just what I'm trying to understand. Again, we can follow up subsequently. I'm not sure it actually it doesn't significantly affect the APIs because by definition, we're using the base APIs for the scenarios that I'm talking about. So from that perspective, it's an implementation discussion rather than an API discussion. But it's still something to be worked through.
Right. I think the big difference is that the stream kind of assumes it's sort of the reading and writing, it's tied together, whereas here it's not. And that's sort of why the socket or the network stream has the shutdown, which says, I'm closing one way or the other, but the Unix stream doesn't.
Yeah, maybe add it to your list of things to follow up on to figure out how it behaves in these situations, and we can move on.
We certainly, I don't know if it answers your question, but we have the conformance stream suite hook into MSQuick stream. So we can look at it I think the current implementation would pass all the tests.
Okay.
And again, I'm not saying it's complete or whatnot, and I don't know necessarily answers for your questions, but we can also
that certainly
write
helps.
our tests.
Then we have to go make sure we have the right tests in the conformance suite. I'm always happy to see more tests added there. It applies to a whole bunch of stream types and makes sure they work equally well. So,
What a pain.
Just to confirm, we have it plugged into that. Sorry, just to confirm, we have it plugged into that with the MSQuick implementation or with the mock implementation or both?
Mock is gone and we did MSQuick.
Okay, great.
Did we talk about the cancellation tokens yet and write async?
We haven't gotten to write async yet.
No. So are we fine with the abort and the quick abort direction and complete writes, or do we want to rename them or change them somehow?
The naming on quick abort direction seems fine. Is this the only place we use it?
Yes.
There's no like abort at the connection level or anything?
No.
Yeah.
Seems okay.
Yeah, I think the problem
is both what we use in shutdown direction.
Once again, please.
For sockets with shutdown, Are these the same names that are used there?
Yeah, I don't know from the top of my head. Sorry.
And just something to check on. In particular, I wanted to make sure. I think it is. I think both is the term that's used for reading and writing.
I think it
in
is.
Which case, it's fine. Quick stream type is
Sorry.
it's a little.
Socket shutdown has receive, send, and both.
Yeah, both is the more relevant one here. Since this is applying to something that's a stream, and the terminology we use on stream is write and read, it makes sense to use write and read rather than receive and send, which is what's used at the socket level. So I think quick abort direction is fine.
Okay.
Although it's interesting that socket shutdown isn't in flags. Huh. Oh. I wonder, is that just mapping to what Win32 used with sockets? It doesn't matter. What you have is fine. I still think we should.
Complete right? Go on.
Oh, keep going. Sorry, go ahead.
And the naming for the complete rights, are we fine with that, or do we want to rename it? Maybe I have a wild idea. What if we kept the naming for the tasks and rename the complete rights?
I would much rather rename the tasks and keep complete rights. Or specifically rename the rights completed. Since I don't think that's what it is. I think complete rights is fine as the name for the method. Complete rights, shutdown rights, done writing. And there's only a limited number of things it could be.
Well, it's basically adjective. One says do something, right? The other one says something happened. So I don't know if.
Yeah. I think complete rights is fine. Emo, you okay with that?
So what is the name again? Complete
rights.
Yeah, I think I'm fine with that. So basically it's the current name, right? Yeah. Yeah, to me the complexity or the I don't know, the issues I see here is not naming. It's mostly about the interactions, and that's just harder to wrap my head around, I guess. Yeah. And I don't think naming will help with that.
So then we come to write async.
And David's gone. What are we going to do without him?
So my two concerns here are, and I totally understand why we want to do it, and it's fine. Maybe we can come up with some approach. Is the first issue is we're doubling the number of overloads to add this end stream thing. And I understand we're trying to do it because even though you could call write async followed by complete rights, we want it to be atomic. So that's one issue. And the second issue is we're adding 2 additional sets of overloads for scatter gather for vectored IO. And the types we've chosen here don't map to the same scatter gathered vectored IO types that we've used in other similar situations. I think on both socket, you can correct me if I'm wrong, but I think on both socket and random access for file IO, we now use read-only list of, well, I think for file IO, I think we use read-only list of read-only memory. And on socket, we use, I don't even remember what we use, but it's not these. So we're adding 2 distinct representations. Now, saving grace is it's just quote quote just overloads, so it's not necessarily adding additional concept count. But I expect that if and when we add a base stream.writeAsync that is for vector.io, and we have an issue open for it, I don't think it will use either of these two representations. I think it would, when we previously added random access in .NET 6, we talked at length about what representation to use, and I'm pretty sure we settled on the one that's used there, which means that in .NET 8 or whenever we add that, we'll have yet a fourth representation, or a third representation that we add to QuickStream here, and a fourth set of write async overloads. I don't know. It feels extensive.
What is the representation? Is it like the read-only list of read-only memory, or what?
I believe that's what we use. I can look. Random access. We use an read-only list of read-only memory, and then socket.
Socket uses something like ilist of array segment.
Yeah, ilist of array segment.
So as far as I know, this is coming from the ASP.NET pipeline. So whatever type is easy map to, I think we might be fine with. But I think it's really up to, I think, Dave and Chris to confirm that.
So when I talked with James about it, he had said that, you know, read-only sequence is the natural thing, but ASP.NET can do what it does for sockets, which is just have a list that it populates and then hand us the list, or hand QuickStream the list. Manu, you had your hand up.
Yeah, I wanted to say that the read-only sequence is for Kestrel. Read-only memory of read-only memory is for us in HTTP client, where we can change the implementation. So if you tell me what are the plans for the scatter-gather in, like, potentially in stream, we can change it here and change the implementation in HTTP client to be prepared for that.
I wish we were doing all of this at the same time. However, these are all preview, right? So we can change the representation in .NET 8 should we choose to. I think in .NET 8, I wish Adam were here, but I think in .NET 8, we should either definitively decide to add the scatter, gather, vector.io methods to stream, or that we never will. And we should snap QuickStream to use whatever the shared type is. I assume that we've measured and vector.io actually makes a meaningful perf difference here.
Not particularly. We don't have a specific numbers for using it and not using it.
Yeah. Also, I think we buffer in HTTP client, so you can like write to the buffer and then we flush, so it gets written kind of together-ish. No, we don't? I thought we did.
No, we buffer the headers, and then if we have buffered headers, we will send them with the first batch of data.
So at best for HTTP client, this is saving one write.
Yep. Yep.
For the whole request.
So
But before we add this complexity, might be worth gathering some perf data to confirm. I could believe if you tell me that it makes a meaningful difference, I can believe that. But before we go and add this complexity, it'd be good to validate that it actually does. I mean, it could very well be that MS QUIC is just taking the multiple buffers, creating its own temporary with everything concatenated and sending out one packet. So we could also just do the same thing. It'd be useful to know, you basically measure just doing the simple thing of iterating through the buffers and writing each out and against copying all into a temporary buffer and writing out that temporary buffer. And if this does provide a meaningful benefit, then we should do it. We want to avoid significant overheads where we can. I'm just a little bit concerned based on previous data gathered that there might not be much of a there, in which case we're adding a lot of complexity for not a whole lot of gain. But if we decide we do need this, I think I would err on the side of using the representation that we think we'll use for stream.writeAsync. Should we add it in .NET 8? We believe that will be I read-only list of read-only memory. And presumably we, at least according to James, if I read his response to it correctly, ASP.NET could adapt to that. And it sounds like HTTP client could adapt to that as well. We can always, the saving grace of preview, we can always change what that overload accepts in the next release before these are final. But Manya, maybe sync with Adam Sitnik as well to confirm my suspicions about what we would use there. It'd be nice to just have one API here instead of two. If we absolutely need it, go ahead and do it. We think Quick Stream is a relatively niche thing that relatively few people will be using directly. So if we have some helpers to help those people, it's not a huge deal. Just be nice.
I would certainly feel we can drop the one we use in HTTP client if we need to, and measure the impact. It seems more problematic to basically remove the API Kestrel currently use without confirming that they have decent workaround.
Yeah, and like I said, if it makes a meaningful, my understanding is there's basically one call site for this in Kestrel.
Right.
And according to James, at least, it wouldn't be difficult to change it. But I would want to make sure that this isn't actually, a significant perf win. So there's multiple
also
levels.
Like the idea of consistency. Yeah. So if we did it on sockets or whatever, and Kestrel knows how to use it, I mean, this actually came out as implementation in 6. Right, so it's kind of pretty old proposal. We implemented it, and Kestrel started using it, but it doesn't mean there is no viable alternative to it.
Yeah. Anyhow, so that's just something to explore. Like I said, at the end of the day, it's not the end of the world if we have all these. My preferences would be that we have either none of them because we determine that vector.io actually gains us nothing, or one of them that uses the same representation as stream.writeAsync will in .NET 8. That's my ideal. But, at the end of the day, they're overloads. If we really believe that these are valuable, it's okay. The end stream thing, if nothing else, it'd probably be nice to name it the same as complete writes. But I don't know. I understand the use case.
Could we have a complete write which takes empty buffer, or make a nullable to buffer, and basically have it a single API?
It would not work with the read-only sequence. Like, you would have to have overloads, one for read-only memory and one for read-only sequence with a complete write.
Yeah,
because one is.
Well, if you can avoid them, then you don't, right?
What is writeAsync waiting for? Like the task that it returns, when does that complete?
When MS QUIC internally buffers the data and lets us know that it has copied the data into their own buffers.
Regardless of whether endstream is true or false.
Yep.
Okay. So it has the same behavior as writeAsync read-only memory.empty has the same behavior as complete writes.
Yep. With endstream true.
With endstream true, yes. Sorry.
Yeah. That's equivalent. That's the same.
But complete writes on its own is valuable because we think that's confusing to force people to call write async with an empty buffer. It's a legitimate reason, I think.
Basically.
Confirming. Okay.
Basically, but I don't think we are the ones actively using it. Maybe
Who
Radek or
uses-
Natalia.
Yeah, who uses Kestrel uses complete writes?
As far as I know, they're using Endstream as well.
So who uses complete writes?
That's what I'm trying to say, that I think no one.
Aha.
Let me do a quick search on the API. What's it called now?
I mean, we don't have many users in general, right? So we basically have two users primarily, which is HTTP client and Kestrel, and they both sit on top of HTTP3. So we don't really have, I think, wide usage data from general audience.
Oh, we use it in HTTP3.
I mean, conceptually, when you have HTTP request, right, you write it, you might not know how big it is, and then when you figure it out, you close it, so the peer knows you are finished.
We are using it in HTTP3. There's like one of the cases, depending whether you have body and whatnot. One of the cases is using explicit stream shutdown.
I see. When you dispose the stream, that's when we call complete writes.
Yeah, complete writes. Sorry, it's named differently in the current API.
Yeah.
Well, for example, to change it to use the empty buffer with the fin flag would be no problem for us, right? Should we choose to?
Yeah, I think that's kind of unfortunate API to force on users, though.
Yep, I agree somewhat.
Again, I don't have a problem with complete writes. It's just there's just duplicated concepts always bug me a bit. I get why it's here. I understand the use case. Let's try and reduce the number of overloads by investigating what we talked about previously around the vectored I/O, and yeah, we'll just double it for Endstream. But again, if you could call it the same, if you call it bool complete writes or something, or
yeah,
or last, I don't know. Maybe Endstream is fine. I don't know. It's just, again, it's the two different, the same concept exposed in two different ways is a little, yeah.
What I'm hearing here is basically try out whether we can live without the write async with read-only memory that's used from HTTP3 client. Get rid of it if possible, if it doesn't have any perf impact. And I guess I'll sync with Adam. And since we're doing preview, we might keep the read-only sequence for Kestrel for this release, and in .NET 8 we might synchronize on the scatter gather shape